afternoon, everyone. I think it's again under the chair. It's not here. Anyone see the pointer? Okay, till the pointer is here, I'd like to introduce myself. My name is Wael. I'm a TAMM AI advisor, and it's my pleasure to be here with you today, and I assume that is easier than using LLMs. Okay, so in today's 15 minutes, we are going to discuss a topic called multimodal machine learning, or multimodal in machine learning. So before we start, who have heard about the term of multimodal? Okay, quite a few numbers. Then we are going to focus on what is multimodal, how do we build a multimodal, some nice examples against multimodals, and then finally, what are the challenges that we face when we build multimodals? All right, let's start with the human senses. How many human senses do we have? 6? 5? 7? I'm aware of 5. Okay, so yes, we have 5 plus the 6th sense that it's logically sense, but we have sight, so we see things, and if we want to translate this to a data representation, it's like a computer vision models or a deep learning models where we convert things from images, frames, etc. to a simple or another representations. And then we have here, so we hear, and then accordingly, if we want to look at this from a data perspective, it's an audio analytics, it's a pictograms of the audios and so on, and definitely we have touch, we have smell, and we have taste. If I give you an object today, and I ask you to recognize this object, what is the most used sense that you are going to use? Eye? Okay, I would say that it depends on the type of the object itself, right? So the ability to recognize objects increases when we introduce more senses or when we combine more senses. And then accordingly, when we convert this to a data representations where we want to build the machine learning models, we have 4 types of modalities that are very popular, and then we have other modalities that are in place. So we have textual modalities, we have audio modalities, we have video, we have images, and then we have different types of data. Let's talk about some examples. Okay, so in healthcare, for example, people or physicians are transforming the way that they are diagnosing things. So instead of just looking at the X-rays and instead just looking at the prescriptions or writing something, they started to combine, or when they want to diagnose a disease, they look at your X-ray, they look at the physical assessment, and accordingly, they come up with a better decision. Same when we look at social media. So let's say I can write something in a social media, I'm not happy about ABC, and then I can have a different photo that does not represent at all what I'm trying to say. And if we look at an example of autonomous vehicles where they use different types of sensors, different types of data, and so on. But what's really interesting is to see a real world multimodal example that we did in TAMM. I'd like to leave you with this 1-minute audio.
Hi, TAMM.
have any pending payments?
So we did not just implemented AI, and we did not just implemented an agentic framework, because what you have seen is a multi-agent framework. We are also introducing the capability of multimodal in the TAMM application. So that's why we have seen TAMM application, the one that we released recently in GITEX, and I suggest that you have a chance to explore it. And then the question is, how do we build a multimodal applications or a multimodal machine learning model instead of an application? So there are 5 approaches when we build a multimodal machine learning. First one is representations. How do we understand the representations of the data? Image versus text versus audio, and so on. And at the end of this slide, there will be a quick quiz to see if we are all aligned. So the next one is co-learning, which is an example of leveraging one modality in the absence of another modality. The question that I asked, if we want to recognize an object, which sense do we use? And the same thing happens when we start building machine learning models. Should we leverage a certain type of data modality, or we leverage combination of these types? And this is a very common use case, and one of the examples is what we call as a zero-shot examples, or zero-shot learnings. Fusion. So if we give a video of someone who is talking, and we ask to extract the text from this video, what are we going to do? Are we going to use the voice and then transcribe this voice to a text, or we are going to use the lips movement and then accordingly we extract the text from the lips movement? So this is so-called as a fusion, which is merging different modalities together to come up with the target. And then translation, which is deciding the relationship between different modalities, meaning if I have an image, like what we have seen in the video, when it was an image, but we also support videos, and then it goes beyond just an object detection, because we are using both the text to transcribe what's happening and then the image to do an image analysis, and then we are combining both of these together to come up with what you have seen as reporting an incident. And last but not least is alignment. In alignment, if we want to accurately align certain objects, meaning if I'm watching a TV and there is a chef who is cooking, and then there is a kind of recipe that is going on the screen, and then the chef is doing ABC, we want to be able to map between the movements, the speech, and what's happening, what we see on the screen. So that's called alignment. If we want to build a machine learning model, we should have at least 2 minimum approaches out of the 5, meaning that the multimodal machine learning won't work without 2 approaches out of these 5. Let's make a guess. What are these 2 approaches that are very highly needed to build a multimodal? Is it a presentation, co-learning, fusion, translation, and alignment? I'll give you 5 seconds, then we'll start. Yes, representation for sure, because we need to see how do we represent the data, but there is something else. Okay? No? We are left with 2. Fusion. If we do not do data fusion, then we cannot end up with having what is the output of this or these 2 modalities together. And if you want to translate this as an implementation or as an actual implementation, there are 3 major approaches or 3 major techniques. Early fusion, or it's also called as information fusion, which is if you are working in machine learning and you want to build a model, you have a modality 1, which is, let's say, voice, and you have a modality 2, which is, let's say, audio. And all you do is you extract the features, you concatenate these 2 features together, and then you feed the model with these 2 features. Or we do something called late fusion, which is you train a model 1, you train a model 2, and then accordingly, the output of these 2 models is concatenated, or what we call as a late fusion, or sometimes it's called ensemble learning. And then the most recent one that is gaining more attention is the joint fusion or the hybrid fusion, in which you have a model 1 and you have a model 2. You are training these models, but instead of looking at the outcome, which is the last layer of a neural network, you take 1 layer before, you extract the features, you concatenate the feature, and then you feed these into a 3rd model that is being trained on what other models have been trained on. So why multimodal is so much important when LLMs came into the picture and they got the big attention back in November 2022, there was no multimodal, right? You were interacting in text, you were receiving text. And then few months later, 4 or 5 months, they started to introduce a multimodal capability. So that's why I personally believe the future is multimodal. As of now, OpenAI recently released the audio preview, which is one of the models or multimodals where they now support image, audio, and text. Challenges to close this up: explainable multimodals. If you are working with machine learning, you would know that it's not that easy to explain a machine learning model. Definitely, we can explain a regression, we can explain a decision tree, but when it comes to neural network, random forest, bagging trees, and so on, it's becoming more difficult. Self-supervised learning, it's a growing concept of eliminating the need to label all of data before you train your model. So it's a self-supervised learning. Ethical consideration. If we are working on a modality 1 and we have our responsible AI framework, we would know that these types of modalities or these types of attributes are being biased or they are contributing much to the model, and then we can have our responsible AI. However, when it comes to merging multimodals together, it's becoming more difficult to understand which modality, at what time of the training, is causing some not aligning with our responsible AI. Human-like understanding, we want to reach to a point where we pass an object, regardless if it's an audio, image, or text, and then have the same kind of human-level understanding. And by that, I would like to conclude this presentation. Thank you for listening to me. If you have any question, I'd be more than happy to respond. Thank you.